Good afternoon, my name is Joe and I will be reviewing ionic compounds. What is an ionic compound? In simplest terms, an ionic compound is when two ions are held together by electrostatic forces, also referred to as an ionic bond. There are positively charged ions, which are called cations, and negatively charged ions, which are called anions. Ionic compounds are one of the more common chemical compounds you will see in chemistry. The compounds can be simple, such as NaCl, which is sodium chloride, where the sodium is the positive cation and the chlorine is the negative anion, or they can be more complex, such as NH4(2SO4), which is ammonium sulfate, where the polyatomic ions act as both the cation and the anion. There are a few characteristics that can be seen to determine if a compound is ionic or not. First, as we discussed before, ionic compounds are made up of positively charged cations and negatively charged anions. In most cases, a metal will act as the cation and the non-metal will act as the anion. However, this is not always the case. To form a compound, both the cation and anion must contain an equal but opposite charge so that the cation is able to accept the same number of electrons that the anion needs to lose. Using the example from before, in the periodic table of elements, sodium needs to lose 1 electron. And chlorine needs to gain 1. Another way to look at this, to visually picture how many valence electrons, which are the outer shell of electrons, each are going to either need to lose or gain, is by using the Lewis dot structure. As you can see, to get to the previous layer of electrons that contain 8 electrons, the sodium ion wants to lose 1 electron. The chlorine ion has 7 valence electrons and needs to gain 1 to become stable at 8. Now that both ions have stable valence shells, the sodium ion has lost 1 electron, so it becomes positively charged. And the chlorine has gained 1 and becomes negatively charged. These opposite charges create a force that pull the two ions together to form the ionic bond sodium chloride with a 1:1 ratio. Most times, these ones are unnecessary to write. However, when you need to use more than 1 ion to balance a charge, you will need to note those, as we'll see shortly. Now that we know how to write an ionic compound with a 1:1 ratio, can we use this same technique to write out an ionic compound that isn't 1:1, such as potassium oxide? The answer is yes, we can. First, find potassium and oxygen on the periodic table of elements to see how many electrons each ion wants to either gain or lose. As we can see here, potassium wants to lose 1 electron, and oxygen wants to gain 2. As we can see from the Lewis dot structure, the 1 electron from the potassium is not going to satisfy the oxygen. So what can we do? Well, we just add another potassium, satisfying the oxygen. With all ions satisfied, they will be attracted together in a 2:1 ratio. Some of the other properties of interest with ionic compounds are that they usually have a high melting and boiling point. They also usually form a very brittle structure and break at their limit of strength rather than bend or twist. And most substances do not conduct electricity very well. This concludes my review of ionic compounds. Thank you for your attention.